PUF1 is a university-discovered strain of a propionic bacterium, both useful in the cheese-making process as well as in the human microbiota.
Continental cheese or Swiss cheese has many distinct characteristics. For one, Propionibacterium Freudenreichi, which is one of the bacteria used in production, consumes lactate, which is a byproduct of other steps of the cheese-making process. When lactate is consumed, acetate, propionate, and carbon dioxide result. Acetate and propionate contribute to the taste of the resulting cheese, giving it a nutty and sweet flavor. The carbon dioxide creates holes or eyes in the cheese. When there is no carbon dioxide production and no holes, the cheese is actually deemed blind. In general, the larger the holes in the cheese, the longer it's fermented and the richer the flavor is. However, when the holes get too big, the cheese isn't cut well. Therefore, the fermentation time must be regulated. Our budget for this project is $325 or $65 per person. We have received permission from the Mohammedzada lab to use their propionate strand PUF1, so we will not need to purchase this. Our funds will go towards buying equipment and supplies for the cheese-making process and reagents for PCR.
The Mohammedzada lab isolated from the feces of human breast milk-fed infants Propionibacterium Freudenreichi strain UF1, but not from formula-fed infant feces. Therefore, being breastfed confers PUF1 to the infant. Propionibacterium Freudenreichi is a gram-positive facultative anaerobic bacterium, and they synthesize propionic acid, and which is useful in cheese making because it contributes to the flavor. They're known as Swiss cheese bacterium. So PUF1 specifically is 10% different genetically than other known propionibacterium species, which caused it to be its own strain, University of Florida 1. The only lab that has access to it currently is the one that I'm in the University of Florida. So we get a very special access to this bacterium for this project. A study done in France that showed that it is possible to make an anti-inflammatory cheese using Propionibacterium Freudenreichi and one other lactobacillus strain to mitigate DSS-induced colitis in mice. We hope to create a product that could do the same thing.
The iGEM competition team at UF plans to synthetically engineer PUF1 to overproduce propionate in order to enhance its immunomodulatory and metabolic effects. Therefore, a future direction for our research would be to use this genetically altered bacterium to make a different type of cheese. The resulting cheese could be compared to our original to detect differences in flavor and eye production. This new cheese could also be tested for enhanced immunomodulatory and metabolic effects in organisms that digest it.
The plan for making the cheese is to allow the cheese to mature for as much as possible after using PUF1 as the starter culture for probably around as close to 2 months as possible, but if it's less than that, we can work with it. Then we will isolate from that cheese Propionibacterium strain University of Florida 1 using some kind of selective media, and if that's not possible, then we can try some kind of selective marker using antibiotic resistance. Finally, we can confirm that the bacteria we've isolated is indeed PUF1 using molecular methods such as PCR, as we have done in this class.